Hello everyone, welcome to my channel Srihari Science Classes. In this class, I am going to explain the concept of interhalogen compounds. So shortly I am entering into the topic interhalogen compounds. That means in between the two different halogens, the compounds are obtaining. They are known as interhalogen compounds. So now the definition of this one: when two different halogens react with each other, interhalogens are formed. So when the two different halogens are combining or reacting with each other, they are giving rise to new compounds. They are known as interhalogen compounds. And so general formulas of interhalogen compounds are XX dash and XX3 dash and XX5 dash and XX7 dash. In these formulas, X is a larger sized halogen, X dash is a smaller sized halogen, and X is more electropositive than X dash. That means X electronegativity is lesser than that of the X dash. X dash electronegativity is high or the more. So that is about the X and X dash. So here one statement I am saying, so as the ratio between radii of X and X dash increases, the number of atoms per molecule also increases. So when there is a more difference in the radius of X and X dash, so the number of atoms per molecule also increases. So for example, IF7, here the X is equals to I, X dash is equals to F, that means fluorine. So there is a large variation in the radius of iodine and the fluorine. So that's why the total number of atoms here, 8 atoms are there per molecule. So that means more number of atoms are existing per molecule. So that is about this statement. And here I am given some examples for the interhalogen compounds: ClF, chlorine fluoride, chlorine trifluoride ClF3, BrF3 bromine trifluoride, BrF5 bromine pentafluoride, IF7 iodine heptafluoride, so etc. These are some of the examples for the interhalogen compounds. Now we will discuss about the preparation of interhalogen compounds and some of the properties and their structures. Now the preparation of interhalogen compounds. The interhalogen compounds can be prepared by the direct combination of halogens. So for example, Cl2, chlorine molecule I am taken, F2. So these two are taken in a equal volume and provided certain temperature, 437 kelvins, 2ClF. Chlorine fluoride, one of the interhalogen compound, is obtained. So for example, another I am taking Cl2 plus 3F2. So here fluorine I am taken excess quantity, 573 kelvins of temperature is provided for the reaction occurring in between these two. 2ClF3, chlorine trifluoride, is the product. And another example I am giving, I2 plus Cl2. Here I am taking equal volume again. So they are reacting with each other. So formation of ICl takes place. So that is about the formation of iodine chloride. Another preparation I am doing. So fluorine I am taken. To this ClF3 is added, chlorine trifluoride. They are reacting with each other. So formation of ClF5, chlorine pentafluoride, is occurring. That is about the preparation of ClF5. And another one I am giving as example, Br2 plus 3F2 gives us to 2BrF3. So boron trifluoride is an interhalogen compound is obtaining in this chemical reaction. So another I am giving as an example, Br2 plus 5F2 gives us to 2BrF5. So boron pentafluoride is the interhalogen compound is obtaining. So these are the some of the preparations for interhalogen compounds. So in these preparations, so we have taken the two different halogens directly combining. In certain chemical reactions, we have to provide certain temperatures for occurring of a chemical reactions for the formation of interhalogen compounds. So this is about the preparation of interhalogen compounds. Now the properties of interhalogen compounds. All the interhalogen compounds are covalent molecules and all are diamagnetic in nature. So here magnetic property also said, so all are the diamagnetic in nature. They are volatile solids or liquids at 298 kelvins, that means at room temperature, except chlorine fluoride. So chlorine fluoride, which is a gas, ClF is a gas, except that one all are volatile solids and liquids. Next property, interhalogens are more reactive, chemically unsaid, than individual halogens. So this is because X dash bond in interhalogens is weaker than X bond. So individual halogen. So in halogens, except FF bond, that means FF bond is a weaker than XX dash bond, and XX bond is a stronger than XX dash bond. So due to this, the interhalogens are more reactive chemically than the individual halogens except FF, that means fluorine. This is about some of the properties of interhalogens. Now we will discuss about the structures of these compounds. Now the structures of interhalogen compounds. Now I am explaining one of the shortcut method to explain the structures of these compounds. So for example, I am taking any one of interhalogen compound, for example X dash. In this molecule, X is the central atom, so X belongs to halogen family. That means there are 7 electrons in the outer shell. So X dash, that is also halogen, that has the ability to form only one single bond. So that is forming with the use of this electron. So now another electrons are there. So they are, I am considering as a pairs. Now the hybridization I am saying S, P1, P2, P3. Now the hybridization at the central atom is undergoing sp3 hybridization. So sp3 hybridization is occurring at the central atom X. So its shape is linear. Straightly I am writing. So X dash. There are the 3 pairs, lone pairs. That is about the structure of XX dash. And in the case of XX3 dash, so similar type of explanation. So sp3 dehybridization. So molecular shape is the bent T shape. So for example, XX3 dash I am taking here. I am explaining the structure again. XX3 dash, central atom is the halogen 3, making with single bonds S, P1, P2, sp3, sp3d. sp3d is the hybridization. So X is the central atom. So here the X dash, here the another X dash, here the another X dash. So remaining 2 pairs like this. That is the bent T shape structure. That is about the structure of XX3 dash. At the central atom hybridization is the sp3d. Now about the XX5 dash. I am taking that molecule here. XX5 dash. So another 2 halogens, they are making single bonds. Now the hybridization. Yes, P1, P2, P3, D1 and D2. sp3d2 is the hybridization. sp3d2 is the hybridization is occurring at the central atom X. The molecular shape is the square pyramidal. So this is about the X. This is x dash, again x dash, again x dash. This one is the square, and one lone pair is there, another is above the plane. That is about the structure, square pyramid structure of x5 dash. At the central atom, hybridization is the sp3d2. Now last molecule x7 dash, hybridization is sp3d3. That means another 2. I am taking x7 dash. 7 x dashes are there and making with the single bonds. Now the hybridization. Yes, p1, p2, p3, sp3 and d1, d2 and d3. Now the hybridization is sp3d3 hybridization is occurring at the central atom X. At this central atom, sp3d3 hybridization is occurring. The molecular shape is the pentagonal bipyramidal. So pentagon we have to draw. So this is about the central atom. So x dash, x dash, x dash, x dash and x dash. So this is about the pentagon. And bipyramid we have to draw. So this is the one of the x dash that is present above the plane. This is another x dash that is present below the plane. So that is about the pentagonal bipyramidal structure. That is about the x7 dash structure, and the hybridization is sp3d3 hybridization at the central atom. So this is about the hybridizations and their structures. So this is a method, easy method, so to explain the structures and hybridizations. So that is very useful in our entrance examinations. So this is about a brief and complete information about the interhalogen compounds. In the next class, I will discuss about next topic,